Welcome to TOC class. Here we should aware of the basic concepts behind structural induction. Comes under inductive step type. So inductive method is used to implement iterations of steps which contains 4 categories in it. One is integer induction, second one is general form of integer induction, and third one is structural induction, last one is mutual induction. So structural induction means it is a structure. We are aware of a data structure concept. So structural induction is mainly used to define some structure concepts in a theoretical way. So this is the structural induction concept. So it is applicable to define a tree or a linked list with some repeated definition of structures. So it can be proved, comes under an inductive step method. So it should have a basic step and inductive step in it. Let us discuss this structural induction. Now we'll take the definition of tree. This tree definition can be written within base step and inductive step method. So consider base step. Base step means you are aware of tree. Tree means it contains some nodes in it. It may be a single node or it may be several nodes in it. So the diagrammatic representation of nodes is called tree. So in a base step we are taking one node. So how can you write a definition for base step? A single node. A single node is called as a tree and that node may be a root node. So if only one node is available in a tree and that node should be a root node of the tree, this will be defined in base step. Let us take the inductive step method. That means already it contains some nodes in it. And now I try to append the subtree. It is left children and right children is there. So I try to add this subtree in the main tree. So let us take, this is a whole tree which contains 3 children in it, and this is a subtree. How can you add it? You can add nt subtree as a subtree of either n1, n2 or n3, or you can directly add this subtree as a child of n. So there are 2 possible ways. Either this particular node will be represented in an existing parent node. Otherwise, you can add that node as a child of this n1, n2 like that. So in this way, a tree can be defined in structural induction method. So this method is only for defining structures like trees and linked list. And the last concept in integer induction proof method is mutual induction. So instead of proving a single statement by a induction method, we are taking group of statements. Group of statements means in a generalized integer induction method, we are taking only one statement. If s of n, then s of n plus 1. Here for s of n, we are taking only one value. Instead of taking one value, we are taking different statements. So two statements or 3 statements like that. So depending upon more than one statements, we try to prove the method, means that is called as mutual induction method. So how can we solve it? For example, I am taking a machine, that means a switchboard, which contains on switch and off switch in it. So initially the switch is in off condition. If I push it, it will go to on state. Again, if I push it, it will go to off state. So this is the general switching mechanism. Okay. Now I try to write 2 different statements, S1 of n, S2 of n. So what is S1 of n? If initially the switch is in off state, at first press it goes to on state, second press off state, third press on state, fourth press off state. So let us consider these four different values. I try to write the statement for S1 of n. What is S1 of n? I write it as the system or switch is in off state. When it will go to off state? When it will go to off state after n pushes. When, if and only if the n value should be even. Consider if the number is n equal to 2 or 4, the switch is in off state. And the second one is S2 of n, the system is in on state after n presses or n pushes. When n is in odd. So these are all two different statements. So this function of system will be proved. So consider A if and only if B. If you want to prove the statement, we should prove it as if A then B, and we should also prove as if B then A. We should prove these two methods only the condition is satisfied. So there are two statements A, B. There are two statements S1, S2. So A means the machine. So this is if and only if statement. The whole of on is A. N odd and even is B. So I am writing this here. A is off state when it is even. On state when it is odd. So we should prove this method by basis step and also inductive step. Here we should consider four different values. What are the values? S1 value. So S1 of if statement, S1 of only if statement. Same things for S2 of if statement, S2 of only if statement. For fourth category we should prove it. So consider the category if you are taking n equal to 0 for basis step. 0 is what? Even. If it is even, the machine automatically goes to off state. So S1 statement is true. But what is the second one? That is S2. N equal to 0, it is not odd. So the machine will not go to on state. Individually, the S1 statement and S2 statements are correct. But if you substitute the value for those two statements, either one of the statement will be true. So this is for basis step. The same idea will be implemented in an inductive step method. So these are all the concepts behind mutual induction. And other automata theory concepts are sets, relations and functions. Set means a collection of unique elements which is represented as open brace and close brace representation. We already know that empty set is represented as pi or null. And if it is countable, it is called as a finite set. If the number is not a countable one, it is called as infinite set. Subset is denoted by a symbol. So what is a subset? A is a subset of B means what are the elements available A which also be available in B. That is a subset concept. Equal set means the number of elements which is available in A and B are equal. So which will be represented like this. Like that, proper sets, other set operations are available. The set operations are union, intersection, difference, Cartesian product and power sets. So these are all the examples for those operations. And the next one is relation. Relation is denoted with a set theory concept. So relation is a collection of set S which is represented with a pair of elements A and B. So how can I say it is represented as A relation with B? For example, capital A is a set of element A and B. What are the relations can be possible? Reflexive, transitive, symmetry. If these three values are satisfied, then those relation is called as equivalence relation. If it satisfies reflexive and asymmetric property with the transitive notations, then the relation is called as partial order relation. And mapping, it is also available in a set theory concept. Either it may be one-to-one mapping or onto function mapping. So these are all the basic ideas behind the concepts of automata theory. So the first part of unit 1 is completed with the basic automata theory concepts and mathematical notations and functions in it. The next class will be discussed with finite automata, which is also an important topic in unit 1. Thank you.